guys, we've got this question now. It says, test at the 5% significance level whether or not a binomial distribution is a good model. We are looking at a study of the number of girls in families with 5 children. It was done on 100 such families, and the results are summarised in the following table. Okay, so when we normally do a binomial distribution, we have an n value, which is 100, but we'd normally have a p-value as well, a probability, and we don't here, so we'd have to work out an estimated probability. Okay, so I've got my table here, and what I've worked out, remember there were 5, these are families with 5 children each. So in total, there are 500 children that they've asked. Okay, so we've got 500 children that they are looking at. And out of those 500 children, what I've done is worked out the total number of girls. So there were 18 families, for example, with 1 girl each. So there's 18 girls there. There were 38 families with 2 girls each. So I've worked out the number of girls there, and so on and so forth. And I've worked out that the number of girls in total were 199 out of 500 children altogether. Okay, so that is going to be my estimated p-value. So I'm just going to work that out on my calculator. 199 divided by 500. So my p-value is 0.398. Okay, so p is 0.398. So I've had to work out my p here. So my H note is that binomial is a good model for the observed data. And my alternative hypothesis is that the binomial is not a good model for the observed data. Okay, and then what I've done is I've worked out the probability of each event happening. So for having 0 girls in a family of 5, and I've used the model where you've got n is 100 and p is 0.398. On my calculator, I used BPD because we are looking at probabilities, individual probabilities, not cumulative ones. So all I've done is I've gone to my calculator and I've put in BPD under distributions. I've put in my x value is 0. I put in n is 100. I put in 0.398, and it just gave me that value there, 0.0791. I did the same for x equals 1. So you just put in x equals 1, n is 100, p is 0.398. It will give you that probability. And you just keep doing it for all the values. To work out the expected values, I do n, 100, times p, n times p. So I just multiplied that probability there by 100 and gave me that. Multiplied that probability by 100, gave me that, and so on and so forth. Now you can see that for the final value, when you've got 5 girls, the expected value is less than 5. And if you remember, if you've got an expected value of less than 5, you're meant to combine these two together, and that's what I've done here. So I've written the table again, 0, 1, 2, 3. Instead of writing 4 and 5, I've just written and more than 3. Okay, and then I've written down the expected numbers, so 7.91. So on, and I've just added these two together to give me 8.54. The observed values, they come from the original table there. Okay, they come from there, and there they are. I've just combined the final two, 10 and 1, to give me 11. And then I've used this formula here, the sum of observed minus expected squared all over expected. So I've done 13, take away 7.91, I've squared it, divided by the expected value, plus 18 minus 26.14, squared it, divided by the expected value, and so on. Okay, and if you add all them up, you'd get 7.22. Okay, and that's your test statistic. Now you have to work out your degrees of freedom. Now, if you remember on the last one, I said it's n, however many values you've got, 1, 2, 3, 4, 5. So we're looking at 5 values. And I said take away 1. Now it would be take away 1 if my probabilities had not, my p-value there had not been estimated. But because I've estimated that probability, it's different. So when you estimate what p is by calculating it yourself, then you don't take off 1, you take off 2. So your degrees of freedom here would be 5n, take off 2, which is 3. And at 5% level, if you go to your tables again, you'd look it up, your critical value is 7.815. So here's my little diagram. That's my test statistic. I got 7.22. There's 7.815. If you get anything above that, you would say it's in the critical region, but it quite clearly isn't. It's smaller. So you say it's not significant, so you don't reject H0. And they say, therefore, there is insufficient evidence to say binomial is not a good model for the observed data. Okay.